Welcome, everyone. So glad you're joining me for this explainer. Look, let's just dive right into some genuinely fascinating and maybe a little bit terrifying new research. It completely challenges how much we can actually rely on delegating our tasks to AI. We hear so much hype about AI agents just taking the wheel, right? Well, a massive new study from Microsoft Research called LLMs Corrupt Your Documents When You Delegate is kind of throwing a huge wrench into all of those expectations. The researchers actually start off by acknowledging this huge cultural shift we're living through right now. The expectation is rapidly moving away from AI just being a simple chatbot that answers our questions. Instead, we're entering this whole new paradigm where we expect to just hand over entire complex documents and let the AI autonomously manage them as essentially a delegated worker. And that brings us to the core concept here, delegated work. You've probably heard buzzwords like vibe coding floating around recently. This is basically a workflow where you and I act as supervisors. You ask the AI to handle a really complex spreadsheet or maybe a piece of code, and, well, because we frankly don't have the time, or let's be real, the patience to review every single cell or line of code, we just kind of blindly trust that it did exactly what we asked. But that brings us to the million-dollar question, doesn't it? What exactly happens to our files when we aren't looking? If an AI is continuously working on a document over a period of time, can we really trust that it isn't introducing silent, invisible errors? Now, to figure this out without having actual humans manually proofread thousands of tiny changes, the researchers had to get pretty creative. So to answer this, they built an absolutely incredible benchmark. They call it Delegate 52. And look, we aren't just talking about a handful of simple text files here. They gathered highly complex, real-world documents, creating 310 distinct work environments spread across 52 different professional domains. We're talking about everything from standard Python coding and database schemas to highly niche stuff, crystallography, weaving patterns, and literally even music notation. It's just a massive simulation of professional knowledge work. Okay, so how do they actually test this? They use something called a round-trip relay. Think of it kind of like translating a document from English to French, and then asking the AI to translate it back to English. Did the true meaning actually survive the trip? So they give the AI a forward edit, like, say, splitting an accounting ledger by category, and then a backward edit, merging it all right back together. If the final document doesn't match the original exactly, the AI messed up. The results here are pretty startling. They ran these relays to simulate 20 interactions. And when you look at the numbers for the absolute top-tier frontier models, we're talking Gemini 3.1 Pro, Claude 4.6 Opus, and GPT 5.4, by the end of the workflow, they had silently destroyed an average of 25% of the document. Yep, a quarter of your content just gone or completely corrupted by routine edits. And guys, it gets worse when you zoom out. When you average the results across all 19 language models tested in the study, a staggering 50% of the document content is completely lost or corrupted over 20 interactions. Half of the data. Poof, just gone, or fundamentally altered. Just imagine asking an AI to manage your company's database and coming back to find half the records subtly corrupted. No way. So, is the AI just bad at everything? Well, not quite. The breakdown of readiness by domain reveals some pretty interesting gaps. The researchers defined a model as ready if it preserves at least 98% of the document. Now, Python was actually the only domain where most models successfully maintain the file. But look at the failures. Music notation, earning statements, subtitles, weaving patterns. There's a massive gap here. The models are decent at programmatic code, but they severely fail at almost all other professional, non-programmatic domains. Now, you might be thinking, okay, the fix is easy, right? Just give the AI better tools. Let it read files directly, execute code, maybe search and replace text automatically. Surely equipping them with that kind of ability stops the degradation, right? Well, let's look at the data. Here's the crazy counterintuitive twist. Giving models tools actually makes them worse at the job. Across the board, models performed worse when operating with tools, incurring an average additional degradation of 6% by the end of the simulation. Actually, let me say that again. Giving them a tool belt literally made them corrupt the documents faster. So why does this happen? The researchers call it agentic overhead. Basically, agents get totally bogged down trying to use the tools. They invoke them multiple times, and they end up consuming up to 5 times more input tokens. This massive context load makes them entirely lose track of the actual task. Plus, complex edits require deep textual reasoning that simple search and replace tools just can't fix. The tools literally become a distraction. This leads to a really concerning reality for knowledge workers. Weaker models tend to just delete content entirely, which, you'd easily notice if a whole paragraph suddenly went missing from a report. But the smartest frontier models, they subtly corrupt the content. They'll drop a single decimal point in a contract, swap a name in a directory, or alter a really subtle relationship in the data. These are silent errors you simply won't catch until it's way too late. And this degradation isn't just a flat rate either. It completely snowballs. The researchers identified 3 key variables driving this corruption: document size, length of interaction, and distractor context. Let's dive into exactly how each of these compounding villains accelerates the destruction of your documents. First up is document size. Larger documents are significantly more vulnerable. If you increase the document size from just 1,000 tokens to 10,000 tokens, the error rate snowballs multiplicatively. It ends up being about 5 times worse. The more context the AI has to juggle while making its edits, the more likely it is to silently drop or twist important details. It's like trying to memorize a whole textbook instead of just a single page. Next is the length of interaction. The researchers extended their simulation from 20 interactions all the way up to 100 to see if the AI eventually settles down and stops making mistakes. Spoiler alert, it doesn't. Even if the AI is just repeating the exact same types of tasks, the errors literally never stop accumulating. It is a continuous, monotonic decline. There's absolutely no plateau. The longer you leave the AI unsupervised, the more corrupted the document becomes. The third variable is distractor context. Now, in real workflows, you often give an AI a huge folder of files, and not all of them are relevant to the specific edit you want right now. The researchers found that if you feed the AI irrelevant distractor files, that distraction actually compounds. If you remove those distractors, performance improves by 2% to 8% by the end of the simulation. Sorting through irrelevant information takes a real cognitive toll on the model, which directly hurts its accuracy. And hey, if you thought this was just a text problem, think again. A small-scale visual test showed something even worse. While the top text models might finish with around a 70 to 80% reconstruction score, image editing models degraded all the way down to a 28 to 30% final score. They are entirely unready for complex, multi-step, delegated visual editing. So what's the ultimate takeaway from the Delegate 52 benchmark? It's incredibly clear. Current frontier models simply aren't ready to be left entirely unsupervised on complex document edits. They're unreliable delegates. They introduce sparse but severe errors that silently corrupt our work. And those errors compound dangerously the longer the interaction goes on, the bigger the file is, and the more distractors are present. It really leaves us with a critical question for the future of knowledge work. As we eagerly task AI with executing more and more of our complex, multi-step workflows, we really have to rethink how much we can blindly delegate. How will we catch the silent avalanches of errors we can't even see? It's a sobering thought for sure, and one we absolutely must solve before we hand over the keys to our most critical documents. Thank you so much for joining me for this explainer, and hey, keep your eyes open the next time you ask an AI to edit your files.